How's it going? Today we're going to be going over chapter 4, lesson 3, and we're going to be talking about relations. So, what we're going to learn in this lesson is how do you represent relations as a set of ordered pairs, a table, a mapping, and a graph. And then we're going to learn how to find the inverse of a relation. So, some of the vocabulary that we're going to have to keep in mind is what is a mapping, what is an inverse. So, when we're representing relations, a relation is just a set of ordered pairs, right? So, a relation can be represented by a set of ordered pairs. It can be represented by a table. It can be represented by a graph or a mapping. So, one thing you'll notice is you've probably had some experience with ordered pairs. You've definitely had some experience with tables and graphs. But the one thing you probably haven't really dealt a lot with is a mapping. So that's what we're going to cover today. So a mapping basically illustrates how each element of the domain is paired with each element in the range, right? Your domain being your x values and your range being your y values. And then studying the different representations of the same relation below, we can see that, right? So here's a relation as a set of ordered pairs. Here's a relation as a table, right? And if you notice, these ordered pairs, these x and y values, are these same x and y values here, right? So they're representing the exact same values, just as ordered pairs as a table. And then here is that same relation represented as a graph. Okay, so here's the point 1, 2. Here's the point negative 2, 4. Here's the point 0, negative 3. So again, this information as ordered pairs, this relation as a table, and this relation as a graph. And then a mapping. So this is the one that we probably don't have as much experience with. And so the mapping typically is when you have the domain, the x values, and then you have the range, the y values, and you're connecting the x value that corresponds to that y value for that ordered pair, right? So we had 1, 2, negative 2, 4, 0, negative 3. So let's look at an example of how to work out one of these problems. So here it says express the relation 3, 2, negative 1, 4, 0, negative 3, negative 3, 4, negative 2, negative 2 as a table, a graph, and a mapping. So they give us a set of ordered pairs, right? There's our relation. So now we're going to go ahead and express it as a table. So if you remember, a table is just the list of x coordinates in the first column and the corresponding y values in the second column. So my table will look something like this, right? All my x values listed here, all my y values listed here. And again, these are just these ordered pairs, right? 3, 2, negative 1, 4, 0, negative 3, negative 3, 4, negative 2, negative 2. Again, these ordered pairs, but now represented as a table. The next one is now as a graph, right? So again, I would take my graph by making my coordinate plane and then graphing each ordered pair. And it would look something like this. Here's the point 3, 2, the point negative 1, 4, the point 0, negative 3, the point negative 3, 4, and the point negative 2, negative 2, right? So this is, again, the relation as ordered pairs, the relation as a table, and the relation as a graph. Finally comes the mapping. So again, this is the one that we probably have the least amount of experience with, but it's not too bad. So we're going to list the x values in set x, and we're going to list the y values in set y, and then we're going to draw an arrow from each x value in the x to the corresponding y value in the y. So it would look something like this. So again, I list all my x values, and I list all my y values, and then I connect. Okay. Now, one thing that you'll notice is I only listed the 4 once in my range, in my y values. If you notice, the 4 does come up twice. Well, in a mapping, when you're listing the range, you don't duplicate the number in the range, just like you would never duplicate the number in the domain either, right? So if a number ever comes up twice, you only have to list it once. And if you notice, here's where you can see that it came up twice, as you can see that there are 2 arrows going to the 4, one from negative 1 and one from negative 3. So something to keep in mind. So the final piece is determining the domain and range. Well, easy enough. We already have our domain here and we already have our range here. So typically when you list your domain and range, you want to make sure you do it in order from least to greatest. Okay, so negative 3, negative 2, negative 1, 0, 3, right? Negative 3 being your least value in your domain, and positive 3 being your greatest value. And then same thing with a range, we would just order them from least to greatest. So There's our range, -3, -2, 2, 4. Okay, going from least to greatest. I already mentioned this, but just kind of want to reiterate it. When you're listing your domain or your range, when you're writing the elements of the domain and the range, if a value is repeated, you only need to list it once. So you're going to list it from least to greatest. You're going to list it from least to greatest, but you're only going to list numbers one time. You're not going to duplicate them in your range, and you're not going to duplicate them in your domain either. Okay. So when graphing relations that represent real life situations, you may need to select values for x or y that do not begin with 0 or do not have units of 1. So let's look at an example. Here we're going to use a relation, right? So it says in 1990, New York purchased 12,000 acres for the protection of bald eagles. The table shows the number of eagles observed in New York during the annual Midwinter Bald Eagle Survey from 1993 to 2000. So is our year and how many eagles were observed during that time, right? So again, we're not starting with 0. It's not going up. Um, these aren't going up by ones. So this is an example of what we're going to be doing. So we have to determine the domain and the range of the relation. We have to graph this data, and then we're going to come up with a conclusion from the graph of this data. So let's determine the domain and the range. Well, remember the domain and the range are x and y. Well, x is typically your time, right? So the year is going to be our x value. So that's going to be our domain. So here's the domain, again, listed from least to greatest, which is nice because it's already listed in that form for us. The next part is our range, right? Our y values, which are these, which again, we're going to list from least to greatest, which again is nice because it's already there. And there are no duplicate values, so we don't have to worry about not duplicating something. Every element only comes up once. So there's our domain, our x values, and our range, our y values. So now let's go ahead and try to make a graph out of this. So first thing I want to notice is the x values go from 1993 to 2000. So on my x coordinate, it probably doesn't make sense to start with 0 and then go all the way to 2000. It'd probably make more sense to maybe start a little bit before 1993, like 1992, and then go a little bit past it, like 2001. So we can adjust our our x-axis to contain only those values. And then for our y values, if you notice, it starts with 102 and it goes all the way up to 350. So there we could start with 0 and go all the way to 400. You always want to make sure that that all of your data fits on your graph. So it's important to think about this stuff ahead of time. So here's something our graph could look like. Again, going from 1992 to 2001, right? Starts a little bit before, goes a little bit after, going from 0 to 400. And then I would just go ahead and plot my points. So in 93, I had 102. In 94, there was 116. 95, 144. 96, 174. 97, 175. 98, 177. In 1999, there was 244. And in 2000, there was 350. So this would be our graph for this data, this relation, these set of points. So what conclusions might we make from the graph of the data? Well, if we're seeing every year, since they bought their land, it looks like eagles are going up, right? The number of eagles has increased each year. This may be due to the efforts of those who are protecting the eagles in New York. Okay, so now let's talk about inverse relations. The inverse of any relation is obtained by switching the coordinates in each pair, right, in each ordered pair. So basically an inverse is the coordinates. And so let's take a look at what that looks like. So this is just the key concept, kind of explaining that we're going to take our whatever coordinate we had, A, B, and we're going to switch it to BA. That's what an inverse is when you flip it. So if this was an example of a relation, right? Here are 4 ordered pairs. You have 2, 5, negative 3, 2, 6, 7, 5, negative 1. The inverse of this relation would be the same ordered pairs except flipped in the other direction. So if you notice, the x values became the y values and the y values became the x values. this is the inverse of this relation. And here's a graph of those points. So in blue, you notice the relation. So here are the blue points. And then the inverse is in red, so these points right here. So one thing I want you to notice is if I were to draw a diagonal line across the graph here, right? If I were to draw a diagonal line there, if you notice, these are mirror images of each other along that diagonal line. So again, if I draw a line right through the middle there diagonally, these are two flipped mirror images of each other, which is interesting. The other thing I wanted you to notice is that the domain of a relation becomes the range and of the inverse, and the range of the relation becomes the domain of the inverse. So if this was my domain and my range, right, my x values and my y values, right, domain, range, the inverse, now the range became the domain and the domain became the range. They also end up flipping, okay? So that's something you want to observe and notice. So let's look at an example. So here it says express the relation shown in the mapping as a set of ordered pairs. Then write the inverse of the relation. So they give us this mapping, which we know can be represented as ordered pairs. So again, x, y, x, y, x, y, x, y. So I'm going to go ahead and write my ordered pairs. Again, I have 2, -4, 3, -4, 5, -7, and 6, -8, right? This is where I get my pairs from. And then the inverse. The inverse is, again, I would just take those x and y values and flip them. So now I have -4, 2, -4, 3, -7, 5, -8, 6. Again, just notice that it's the inverse of that relation. It's just the x and y value flip. And then the mapping of the inverse is shown here on the right. Again, if you notice, it looks just like the mapping up here, except now the y values are the x values and the x values are the y values. And again, we're going in this direction where each x coordinate is now mapped with each y coordinate in that direction. So that's relations and mappings and inverses. Let me know if you guys have any questions. Thanks for watching.